This videotape will show you the cutters commonly used in a vertical milling machine and how to set up and perform machining operations on this versatile machine. To properly use the vertical milling machine, the machinist must have a thorough knowledge of cutting tools and their capabilities, machine setup, and machining operations. After watching this videotape, you should be able to write down the safety precautions to be observed when operating a vertical milling machine, identify common cutters used on the vertical milling machine and common devices for holding and driving these tools, describe the procedures for setting up a workpiece to be machined on a vertical milling machine, and describe the procedures for machining a workpiece on a vertical milling machine. Observe these safety precautions when operating a vertical milling machine. Always wear eye protection. Wear short sleeves or roll your sleeves above the elbows. Remove rings, watches, and other jewelry. Make sure that all machine guards are in place. Keep the area around the machine clean and mop up coolant spills. Use a brush to remove chips and never use air hoses to clean a machine. Use a brush or specially designed small tool to clean T-slots. And handle cutters with care, since they have sharp edges. The vertical milling machine owes much of its versatility to the variety of cutters available to the operator. Some of the more common cutters are end mills, fly cutters, and drills. End mills come in various shapes and sizes, and most are manufactured with 2 or more flutes. 2-flute end mills can make their own starting holes, an operation generally called plunge cutting. End mills may be single or double-ended. Double-ended mills are often more economical, giving the operator 2 cutters from 1 piece of tool material. Other end mills are the T-slot cutter and the angular end mill for cutting angles. Shell end mills require a special holder and are of a larger diameter. A roughing or hogging end mill has many cutting edges for taking heavy cuts. This design reduces the possibility of vibration or chatter, but will result in a rougher finish than is possible with a standard end mill. An inexpensive face milling cutter is the fly cutter. This is a single point cutter and used for straight milling operations. It can be adjusted to cut a variety of diameters. The vertical milling machine uses several cutting tools that can also be used on other machines, such as drill presses and engine lathes. Drill bits, boring tools, and reamers are used on the vertical milling machine. These tools are held in a collet or drill chuck mounted in the milling machine spindle. Consult the machinery's handbook to find the correct feeds and speeds for drilling on the vertical milling machine. There are a number of different holding devices for cutters. A solid collet fits the exact size of the tool. It holds and drives the tool with 1 or 2 set screws which engage in a flat portion of the tool shank. The split collet holds and drives the cutter by squeezing the tool shank. The collet is closed around the shank with a drawbar which pulls it into the taper of the spindle. The split collet must be used with caution, since a heavy feed rate or dull tool will tend to pull the tool out of the collet. This type of collet holds the shell-type end mill. The shell fits on the arbor of the collet, and a large screw on the end of the collet holds it in place. This device uses a key to drive the cutter. The quick change tool holder has a head to fit in the spindle and an adapter which accepts the tool shank. This device enables the operator to change tools and setups quickly. For precision machining on the vertical milling machine, check the milling head for alignment. Secure a dial indicator in the machine spindle. This instrument should sweep a circle just slightly less than the width of the table. Bring the indicator point into contact and deflect the needle. Lock the quill. Tighten the knee clamping bolts to take up any front sag in the knee. Set the indicator to 0. Check the setting on the back of the table, then on the front. If the readings are different, loosen the clamping bolts one at a time and then retighten them to give a slight drag. This drag allows fine adjustments without the head shifting. Split the difference between the two indicator readings with the head tilting screw. Then, check the alignment again. Continue this operation until you have the same reading at both positions. Then, tighten the clamping bolts and recheck the head to make sure it did not move out of alignment when the bolts were tightened. When the head has been aligned square to the cross-feed direction of the table, it must also be aligned to the longitudinal direction of the table. The procedure for this alignment is the same as that for the cross-feed axis. After alignment has been made in the longitudinal direction and the bolts tightened, recheck the alignment and make sure that the head is tight. The spindle head is now perpendicular to the table in both cutting directions. If the workpiece is to be clamped to the table, use holding clamps placed in the T-slots. Make sure that the clamps will not interfere with the cutter. Tighten the clamps slightly and place the indicator point against the edge of the work. Zero the dial and move the table to check the alignment of the work. If the milling machine table is equipped with a rapid traverse, the rapid traverse may be used to move the indicator tip along the work. Be careful not to run the indicator off the end of the work, since this could damage the indicator. Move the indicator away from the work and tap the work into alignment with a soft hammer. Then, recheck the work for alignment. When the work has been properly aligned on the table, remove the indicator from the spindle. Another way to hold a workpiece is in a machine vise. The swivel-type machine vise turns 360 degrees for angular cutting and allows setup changes without unclamping the vise from the table. Vices can be aligned with a dial indicator using the same procedures as was used for work clamped to the table. With a vise aligned and clamped tightly to the table, we are ready to perform an end milling operation. For this demonstration, we will square the end of a workpiece to give a reference point. Then, machine a groove in the corner of the work as you see in this finished part. Use parallels to hold the work above the surface of the vise so that the cutter will clear the vise jaws during the machining of the groove. Place small pieces of paper on top of the parallels to indicate when the work is securely seated in the vise. Place the workpiece on the parallels with the end to be squared extended past the side of the vise. Tighten the vise and seat the workpiece with a soft hammer. When the paper will not move, the workpiece is securely seated. We will use a 1-inch diameter, single-end, 2-fluted end mill for squaring the end of the workpiece. Place the end mill in the spindle and tighten the drawbar. The workpiece is low-carbon steel with a recommended surface speed of 80 to 140 feet per minute for end milling. We will use a surface speed of 100 for our calculations. To determine the spindle RPM, you can use either the machinery's handbook or a speed and feed calculator. For this demonstration, we will use a speed and feed calculator and set it to the cutter diameter of 1 inch. Using a surface foot speed of 100, we see that the RPM is approximately 390. Set the spindle speed as close to 390 as possible. In this case, it will be 325. For feed rate, we can see that for soft steel with a 1-inch end mill, we can take from 2 to 5 thousandths per tooth. Using 2 thousandths per tooth will give a smoother finish. A calculator setting for 2 teeth at 325 RPMs and at 2,000 feet per tooth will give the feed rate in inches per minute, or approximately 1.3 inches. Set the feed rate on the table for 1.3 inches. This machine is only equipped with longitudinal power feed, so a hand feed must be used to square the end of the workpiece. Turn on the spindle. Bring the end mill down past the end of the work with the spindle lever. Lock the spindle in place. Then move the work over with the longitudinal feed and pick up the cut on the end of the work. Move the work toward the back of the machine to clear the end mill. Feed the table in 40 thousandths, then lock the table. Coolant may be used to prolong the life of the end mill. Use the cross feed to move the workpiece across the end mill to square the end. The workpiece is fed against the rotation of the cutter to prevent the milling cutter from pulling. The squared end will be a reference point for other operations. When the end has been squared, set up to cut the groove in the corner of the work. Move the workpiece so that the edge of the end mill is just over the side to be machined, and lock the spindle in place. Unlock the table and raise it to touch the end of the end mill to the work. Lock the table and zero the micrometer dial on the knee. Move the cross feed so that the spindle is in front of the work. Then unlock the knee and raise it for a depth of cut of 1/4 inch. Take the reading directly from the micrometer dial. Using the cross feed, move the table out to pick up the cut on the corner of the work. Touch the tool to the side of the workpiece. Then set the cross feed dial to 0. Move the end mill to the end of the workpiece. This groove will be 1/2 inch wide, so move the cross feed out 1/2 inch, using the cross feed dial as a guide. Lock the cross feed. Bring the work close to the end mill by hand, and then engage the power feed, machining the groove in one pass. If a very close tolerance is required, rough the groove, and then use a micrometer to measure the workpiece. Then, reset the dials for a finishing pass. Next, we will machine a 1/2 inch groove, 1/8 inch deep, and 2 inches long in the top of the workpiece. The 2-inch dimension does not include the radius left by the end of the mill at each end of the groove. To position the cutter for this groove, an edge finder is placed in the spindle to pick up the edge of the work. Move over 1/2 the diameter of the edge finder, which places the center of the spindle over the edge of the workpiece. Then move in 1 inch 750 thousandths to position the center of the groove. Then move to the end of the workpiece and pick up the end of the work with the edge finder. Move over 1/2 the distance of the edge finder, placing the center of the spindle over the end of the work. Then move in 2 inches to position the end of the groove to be cut. Now set the longitudinal feed dial to 0 on the right end of the table and set the cross feed dial to 0. These settings are now reference points for the groove. Drop the knee and remove the edge finder. Place a 1/2 inch end mill in the spindle collet. Reset the spindle RPM. Use a 100 surface foot speed. With a 1/2 inch end mill, the RPM should now be approximately 800. Set the RPM to the closest setting on the milling head, which is 660 RPMs. Using the spindle quill lever, bring the spindle down so that the end mill almost touches the work. Lock the quill. Then raise the workpiece to touch the end mill. Zero the dial. Raise the table 1/8 inch using the dial as a reference. Lock the knee and using the hand feed, feed the end mill along the groove to a length of 2 inches. Use the micrometer dial on the end of the table to determine the 2-inch length. The final operation to complete the part is drilling. The first hole is on the center line of the groove, so we do not have to pick up the front of the workpiece again. The holes are also referenced from the end of the work, so return to the 0 setting to find the end of the work. The position for the first hole is 1 inch in from the end of the workpiece. Mount a center drill and reset the spindle RPM. Center drill the first hole. Move the table over 4 inches. Now center drill the second hole. Then move back to the position of the first hole and change the center drill to a 1/4 inch drill. Since the tolerances on these holes are not tight, we will not lead drill for the 1/4 inch drill. Set the spindle RPM for the 1/4 inch drill and drill using lubricant as you drill. Move to the second position and drill the final hole. The holes need to be chamfered with a countersink. Place the countersink in the drill chuck. The reference points are the 0 settings on the dials. Position the countersinks in the drilled hole and lock the spindle. Raise the table until the chamfer has an outer diameter of 1/2 inch. Then set the micrometer stop. Raise the countersink out of the hole with a quill handle. Move to the second hole. Bring the spindle down to the stop to machine the chamfer, and the part is complete. Let's briefly review. You have been shown safety procedures, cutters commonly used on the vertical milling machines, common devices for holding and driving these cutters, procedures for setting up work to be machined on the vertical milling machine, and procedures for machining a workpiece on a vertical milling machine. The vertical milling machine is one of the most versatile machines in the shop. A thorough knowledge of this machine is essential in the machinist's trade.